Top 10 ways quantum physics changes everything we thought we knew. Have you ever wondered if there's more to our world than meets the eye? Imagine a world where tiny particles can be in two places at once, where two particles can be connected no matter how far apart they are, and where just by looking at something, you can change it. Sounds like something out of a science fiction movie, right? Well, welcome to the mind-bending world of quantum physics. Quantum physics is the study of the smallest things in the universe, atoms and the even tinier particles inside them. At this super small level, the rules of everyday life, like how a ball rolls down a hill or how a car drives, simply don't apply. Instead, a whole new set of bizarre and fascinating rules takes over, changing everything we thought we knew about reality. It's like discovering that the universe has a secret level with its own special game rules. For centuries, scientists like Isaac Newton helped us understand how things work in our regular-sized world. But when we zoom way, way in, down to the quantum level, things get seriously weird. These strange rules aren't just for super smart scientists in labs. They are the fundamental building blocks of everything around us, from the glow of your smartphone screen to the way the sun shines. Understanding even a little bit about quantum physics can open your mind to incredible possibilities and help you see the world in a whole new light. So, buckle up. We're about to explore the top 10 ways quantum physics completely shakes up our understanding of the universe, introducing you to some of its most amazing ideas like superposition, quantum entanglement, and the famous observer effect. Get ready to have your mind blown. 1. The mind-bending magic of superposition. Being in two places at once. Imagine you have a coin and you flip it. Before it lands, it's spinning in the air. Is it heads or tails? You don't know yet, right? In quantum physics, a particle can be like that spinning coin, but even weirder. It can be both heads and tails at the same time, until you actually look at it. This incredible idea is called superposition. Think of it like this. A quantum particle, such as an electron, isn't just in one specific place. Instead, it exists in a cloud of possibilities, occupying all its possible states at once. It could be here, or there, or even a little bit of both. It's only when we measure or observe the particle that it decides which state to be in, like the coin landing on either heads or tails. Before the observation, it's a blurry mix of all its options. This means that at the quantum level, things aren't as fixed as we experience them in our everyday lives. Quantum superposition is a core concept that challenges our common-sense idea of distinct locations and states. 2. Spooky action at a distance, the wonder of quantum entanglement. Have you ever heard of two people who are so close that they seem to know what the other is thinking, even when they're far apart? Well, quantum entanglement is kind of like that, but way more intense and mysterious. It describes a situation where two or more quantum particles become deeply linked, no matter how far apart they are in the universe. When particles are entangled, they are connected in such a way that if you measure a property of one particle, you instantly know the corresponding property of the other, even if they are light years away. It's like having two specially prepared coins. If one lands on heads, you instantly know the other will land on tails, without even looking at it. Albert Einstein famously called this spooky action at a distance because it seemed to defy the idea that information can't travel faster than light. However, it's not actually sending information faster than light. It's more about a pre-existing correlation. Entangled particles share a unified quantum state, meaning their fates are intertwined, leading to incredible possibilities for future technologies. 3. The curious case of the observer effect. Does looking change reality? This one is truly mind-bending. Imagine you're watching a shy little animal in the wild. If it knows you're watching, it might change its behavior, right? In the quantum world, something similar but far more profound happens. The observer effect suggests that the act of observing or measuring a quantum particle can actually influence its behavior and even its state. A famous experiment called the double-slit experiment beautifully shows this. When tiny particles like electrons are fired at two slits, they act like waves, creating an interference pattern on a screen behind the slits. But here's the crazy part. If you try to observe which slit the electron goes through, it suddenly stops acting like a wave and acts like a particle, passing through only one slit. It's as if the electron knows it's being watched and changes its mind. This doesn't mean that consciousness itself changes reality, but rather that the act of measurement, which involves interaction with the particle, forces it to choose a definite state. The quantum observer effect highlights the active role of measurement in shaping reality at the smallest scales. 4. Quantum tunneling, walking through walls, kind of. Have you ever wished you could just walk through a wall? In our everyday world, that's impossible. But in the quantum world, particles can do something very similar. It's called quantum tunneling. Imagine a tiny ball trying to roll over a hill. If it doesn't have enough energy to go over the top, it simply rolls back down. But at the quantum level, there's a small but real chance that the particle can tunnel right through the hill, even if it doesn't have enough energy to go over it. It's like the particle temporarily borrows energy to get to the other side, or it simply ceases to exist on one side and reappears on the other. This strange phenomenon is incredibly important. It's how the sun generates energy. Nuclear fusion relies on hydrogen atoms tunneling through an energy barrier, and it's also crucial for how modern electronic devices like flash memory work. So, while you won't be walking through walls anytime soon, quantum tunneling shows how surprisingly permeable boundaries can be for incredibly tiny particles. The uncertainty principle. You can't know everything. Imagine trying to pinpoint exactly where a buzzing bee is and how fast it's flying, all at the same time. The faster it flies, the harder it is to say exactly where it is, and vice versa. In quantum physics, this isn't just a challenge of measurement, it's a fundamental rule of the universe called the Heisenberg uncertainty principle. This principle, discovered by Werner Heisenberg, states that you can't know both the exact position and the exact momentum, speed and direction, of a quantum particle at the same time with perfect accuracy. The more precisely you try to measure one, the less precisely you can know the other. It's not about our measuring tools being clumsy, it's a built-in feature of reality itself at the quantum level. This means that there's an inherent fuzziness to the quantum world, and we can never have a complete, precise picture of everything all at once. The quantum uncertainty principle is a cornerstone of quantum mechanics, showing the limits of what we can know about the subatomic world. Quantum fields. Everything is a ripple. When you throw a pebble into a pond, it creates ripples, right? In quantum physics, instead of thinking about individual particles floating around in empty space, scientists often think about quantum fields. Imagine the entire universe isn't made of tiny solid balls, but rather a vast ocean of different fields. Each type of fundamental particle, like electrons, protons, and photons, is actually an excitation or a ripple in its own specific quantum field that stretches throughout all of space. So, an electron isn't just a tiny ball, it's a ripple in the electron field. A photon, a particle of light, is a ripple in the electromagnetic field. When these fields get excited in a particular way, we observe them as particles. This idea completely changes our understanding of what matter and energy really are, showing them as different manifestations of these fundamental fields. Thinking of the universe as a collection of interacting quantum fields helps explain many of its most profound mysteries. Wave-particle duality. When is a particle a wave? Remember the double-slit experiment we talked about with the observer effect? That experiment also beautifully illustrates another mind-bending quantum concept, wave-particle duality. In our everyday world, things are either waves, like ocean waves or sound waves, or particles, like a baseball or a grain of sand. They can't be both, right? But at the quantum level, particles like electrons, photons, and even atoms can exhibit properties of both waves and particles, depending on how you observe them. Sometimes they act like tiny, solid bits of matter, and other times they spread out and behave like waves. It's like a superhero who can switch between two different forms. This duality means that our classical ideas of what something is break down at the smallest scales. It's not that a quantum particle is sometimes a wave and sometimes a particle. It has an inherent nature that encompasses both possibilities. The wave-particle duality of matter and energy is a fundamental concept in quantum theory, highlighting the bizarre nature of the subatomic world. 8. Quantum tunneling in action, making the sun shine. We briefly touched on quantum tunneling, but it's so important that it deserves its own spotlight, especially because it literally makes life on Earth possible. The sun, that giant ball of fire in the sky, shines because of a process called nuclear fusion, where lighter atoms combine to form heavier ones, releasing enormous amounts of energy. But here's the problem. For fusion to happen, atomic nuclei need to get incredibly close to each other. They both have positive charges, and positive charges repel each other, like trying to push two magnets together with their like poles facing. To overcome this repulsion, the nuclei need extremely high temperatures and pressures. Even with the sun's scorching heat, the particles don't actually have enough energy to overcome this electrical barrier on their own. This is where quantum tunneling comes in. Because of the strange rules of quantum physics, some of the hydrogen nuclei can tunnel through this energy barrier, allowing them to fuse together and release the energy that powers the sun and ultimately life on Earth. It's a fantastic example of how quantum mechanics impacts the largest objects in our universe. 9. Quantum computing, the future of super smart machines. Imagine a computer that could solve problems in minutes that would take today's most powerful supercomputers billions of years. Sounds impossible? Not with quantum computing. Our current computers use bits that are either a 0 or a 1. Think of them like a light switch that's either on or off. Quantum computers, however, use qubits. Thanks to superposition, a qubit can be both a 0 and a 1 at the same time. And thanks to entanglement, multiple qubits can be linked together, meaning they can process vast amounts of information simultaneously. This allows quantum computers to explore many possibilities at once, making them incredibly powerful for certain types of calculations, like breaking complex codes, discovering new medicines, and creating incredibly accurate weather forecasts. While still in its early stages, quantum computing technology promises to revolutionize many fields, offering unprecedented computational power that could unlock solutions to some of humanity's biggest challenges. 10. The multiverse theory. Are there other yous out there? This is one of the most mind-blowing ideas that stems from quantum physics, though it's still a theory and a subject of much debate: the multiverse theory. Remember how in superposition, a particle exists in all possible states until it's observed? Some interpretations of quantum mechanics, like the many worlds interpretation, suggest that every time a quantum measurement is made and a particle chooses a state, the universe actually splits into multiple parallel universes. In one universe, the particle takes one path. In another, it takes a different path. This means that for every possible outcome of every quantum event, a new universe branches off. So, if you made a choice this morning, there might be other universes where you made a different choice. This theory suggests that all possibilities are realized in some universe somewhere, leading to an incredibly vast and complex multiverse. While highly speculative, the idea of a quantum multiverse pushes the boundaries of our imagination and shows how deep the implications of quantum physics can go.